Hi there, Philip from Minecode here. In this video I will be talking about the rigid bodies and I will be explaining properties of rigid body. So without any further waiting, let's start. One more thing, if you would like to start up from the same project as I am running now, you can simply just open the link in the description of this video. There is a zip file, which is a starting project. You can just unzip the file and you can open this file in a Unity Hub. Okay, just simply go to Unity Hub, add project here, unzip it, and add the starting project, which will be this project I am running now. After opening of the file, if you don't see this project, you can just go to Assets down here and open the scenes and open the sample scene. This should be scene you are seeing right now. All right, so now we can talk about the rigid body. So you are using the rigid body whenever you would like to interact with the physics. So whenever you would like to interact with your game object, and this game object should be interacting with the physics. Okay, because Unity is trying to simulate the physics of real world. So of course you would like to sometimes in our game apply the physics to our game object, such as, for example, gravity. Okay, so let's go. Actually, let's explain first gravity. We'll start from the middle here, gravity. So whenever you are using gravity, as you can think, when I will go on the edge and I will fall off from the platform. By the way, you can navigate here with the arrow keys. So you can move with the arrow keys or with the keys WASD. When you will go off the platform, you are falling. That's the gravity. All right. So when I will untoggle gravity, I'll play this game and I will go down and I will simply not fall because there is no such a force as a gravity now. Okay, so that's the gravity. Let's pause the game or let's shut down the game and let's toggle gravity back. I'm sorry for interrupting this lecture, but I would like to just remind you that if you are looking for the extensive course on how to build the games in Unity, then you can find such a course at Encode Academy. You are going to build 3 full-grown games in Unity, starting with the basic stuff and finishing with a fully featured RPG genre game where you can fight, explore, and complete quests. So, in case you are interested, you can check all the information at academy.encode.com. Okay, now let's talk about the mass. So, what's the mass of the game object? Basically, is saying the more mass you will provide, the heavier the object basically is. You can see it when we will create a second game object. Give me a second. Let's just go to hierarchy and right click here, create a new 3D object of the cube, let's say. And let's move the cube somewhere. Let's say on a position 1, 0, 1. Let's move it a little bit to the right. All right, and let's provide a rigid body also to the cube. Let's add a component here, rigid body. Simply select here rigid body and let's leave it as it is now. Okay, now let's play the game and let's try to crash into the cube. You can see we can crash into the cube and there is something happening with our player. We are rotating on the y-axis. So just to prevent now to not rotate, just for example of this, let's go to rigid body and here you can see freeze rotation when you will click on the player. We are already rotating rotation the X and the Z, so let's rotate also Y direction. Okay, let's play the game. And let's try to crash into the cube, and now you can see we are moving the cube normally. Okay, we are interacting normally with the cube as we would in the, let's say, in the normal life, in the real life, when the two objects will collide. Okay, what will happen when the one object is much heavier than the other one? Let's say cube will be 1000 times heavier than their player, so the mass will be 1000. Our player has a mass only 1. So it will play the game and it will try to crash into this much heavier game object. You can see I cannot simply move it. The cube has a much bigger mass as I do as a player. So that's the mass. All right, so now let's continue with the drag. You can imagine drag as the air resistance. This you will usually see when you will apply some forces to your game object. Either it can be force in any direction force, but we can imagine it now easier when we'll be falling with our player. Let's play the game and let's try to fall here. So I will fall, all right? So down here you can see I'm falling normally, okay? There is the air resistance drag is actually 0, okay? So there shouldn't be any resistance. Let's increase it to the 5, let's say. let's play the game now. And let's try to fall off now of the platform. So I will move here. You'll see I'm moving much slower. And I will even increase it more. Okay, I will go one more time. I will increase it even more. Okay, so let's play the game and increase it to the, let's say, 7. Let's play the game. I will increase the drag. I'm barely moving when the drag is 20 already. Okay, see, I'm moving super slow. I will provide here 0 back and I will be falling. Okay, so that's the drag. Okay, we can also see force when we'll apply to the side of this rigid body. I will just move this game object somewhere else. Let's say on a position. Let's move it on position on the X on the 9, let's say, and the Z 9. Let's say here. And I will apply the force like this to the middle of the plane. So the force will go some force I will be applying like this to this game object. All right, so now we need to open our script. You can find the script in the assets folder, player controller. I will open it. Here's a script. I will just I will comment out move position for a second, and I will apply here force. So m_rb, which is a rigid body, and add force. And I will add here force. You need to add here vector on which you are applying the force. And I told you this will be force, like let's say 9f0, and or it will be minus 9f, and here as well minus 9.0f. I'm applying here minus 9 because it will be position of this. I will show you. Okay, so when my current position of the player is 919, and I am applying force to the player of minus 9, 0, minus 9. So when I will subtract it, it will be 9 minus 9 is 0. 1 minus 0 is 1, and 9 minus 0 is 0. Okay, so I'm basically applying force in this direction here. So this will be 0, 1, 0. So direction of the force will be here. That's how the force will be strong. Okay? Like this. So I will hide the screen brush tool. And let's go back here. So that's the force, minus 9, 0, 9. Okay, I will move this game object from the way because I should be moving now in this direction. So we'll play the game, the force will be applied to the game object, and you will see I'll be pushed in this direction. Okay, so you can see that's the force I'm applying to the player. And since I have a drag, you can see I'm moving very slowly. When I will place here drag 0 again, I'll be moving very fast. There is basically no air resistance, and I'm spinning up from the plane. I will provide a bigger drag. It will be much slower. Right, like this. Okay, so that's the drag. Angular drag is something similar, but that's the rotation drag. Okay, so let's leave here the 0.05 or even smaller value. You can provide here 0.0001. And let's unfreeze rotation on the y-axis. So I'll unfreeze it, I will play the game, and I will try to crush this cube from the side. Oops, I am still applying this force. Let's go back to coding editors. And I will simply uncomment this, and I will comment add force. Okay, and all this code, guys, here is explained in my movement video. I'm explaining these different ways how to move the game object. You can find it in the description as well, or you can just find my on my channel. Okay, so I'll continue this. I will play the game, and I will try to hit this cube from the side. So I will be rotating. Okay, so like this, I'll try to hit it as strong as possible. So I'm rotating a lot. I think I'm not able to hit it strong enough, so you will see the actual rotation. But you can see that I'm definitely rotating as I will hit this game object from the side. Okay, so I am keeping rotating. Right, like this. The rotation is rotation is still performed. So when I will increase angular drag, let's say for the value 10. All right, this. Okay, I'll just verify what's the maximum value of the angular drag. Okay, it can go to the infinity. Okay, so let's say a value of 10. You will see I'll just rotate, but I will not continue in the rotation. Okay, you can see even that You cannot even see them rotating on the Y direction. Okay, maybe it will help when I will click on the cube and I will provide here mass back to the 1. Let's try it now. Okay, so I'll try to, yeah, now you can see it more clearly. So I will just rotate a little bit, but I'm not continuing in the rotation. Okay, comparing with some super small value, let's say angular drag of 0. Let's make sure that you are in a player actually. So let's click on the player and provide here angular drag of 0.0001. Let's play the game. You will see I will hit the game object. I will keep rotating because there is very small angular drag. Like this, you can see. I keep rotating. Okay, comparing to the bigger values, where I'll just rotate, there is a big drag, so I will not continue in the rotation. Yeah, so see, just small rotation, and I'm not continuing in the rotation. Okay, I think that's enough of a drag. So we have explained mass, drag, angular drag, use gravity. You know what to do with the use gravity. Is kinematic, that's very interesting one. Let's apply on the cube is kinematic. When the object is kinematic, no forces are applied on the game object. So basically now when I will hit this game object, it will happen nothing because I cannot exchange the forces between game objects. It's because the game object is kinematic. You can see I cannot rotate it, I cannot move it, even though I'm pushing the game object. You notice my cube has the same mass as I do, so I should be able to move it, but it simply doesn't work any longer because this game object is kinematic. Okay, so that's the property of a kinematic. Whenever you will enable it, then no forces are applied to the game object. Okay, so we can untoggle it. Interpolate, it's something you will maybe use when you'll be already using normal model for your player, maybe some model of the player, so maybe some character with normal legs and the hands. All right, so you need to interpolate here usually when you have these models because the graphics of the Unity are computed in the update function, and the physics are computed in the fixed update function. So sometimes these two steps are out of the sync, so you need to sync them. You need to synchronize them in order that the graphics is synchronized with the physics of your game object. So you will usually use it for a specific cases when you will see that your animation of the player is a little bit jittery or it is a little bit lagging. Then you need to think of it that you need to maybe interpolate here. Okay. All right, so collision detection. This you also sometimes when you want to detect collision of your game object, but you will notice that your game object is not colliding properly, and then you need to just check the collision detection. Okay, usually you will use here continuous dynamic when your object is moving too fast. We can also check the documentation. If you're not sure about any property of this, just simply open your browsers and search here for Unity Rigidbody. Unity Rigidbody. This will open documentation. This will search for a documentation. Usually documentation is starting with a docs. So docs.unity3d.com. You will click on this, and here you will find everything about the Rigidbody. If you want some homework, it's very useful to read also documentation. I am highly encouraging it. So what we are looking for, we are looking now for collision detection, right? So you will simply go here, collision detection. Okay, here collision detection mode. I think we are looking for this, right? And we can see the different modes you can provide. So, for example, you can read here, use this to set up rigid bodies for continuous collision detection, which is used to prevent fast-moving objects from passing through other objects without detecting collisions. Okay, so for the best result, set this value to continuous dynamic for the fast-moving objects. So in the case our player will be moving super fast on the game, super fast, we could set it to continuous dynamic here. And when your other object is moving too fast and you would like to check the detection on other game objects when they are colliding together, then on the other game object, you will set the collision detection of continuous. I think it's also in documentation here. Yeah. Okay, so for fast-moving objects, continuous dynamic, and for the other ones that needs to collide with these fast-moving objects, continuous. And also you can read here the rest of this. But usually you will leave it for this, create for the best results, for the best performance results. But in a specific cases, when your objects are moving too fast, you will choose here a different option. Okay, so constraints here, let's click on the player. Constraints XYZ, you will just constrain the position transform. So if you will constrain everything, you will not move at all because you basically freeze the position. So I cannot move now. I am pressing the keys on the keyboard, I cannot move. I will unfreeze the X position and now I should be able to move left and right. I will unfreeze Z and I should be able to move up and down. Okay, so that's a freeze position. Freeze rotation is the same, but this is applying to the rotation of the game object. If I will untoggle everything, I will basically fall on my nose with this game object because I enable rotation. So you can see now I should be able to fall with my player. Let's hit this. Oh, you can see I'm already falling. I will click here scene. You can see I fell down. Okay, because my game object is not even. My game object is not even. You can see it's not the even surface. So of course the forces are applied to it, and it's not stabilized on the ground. So that's why we are falling, and that's why I froze the rotation on the X and the Z. All right. All right, guys. So that's all of the properties of the rigid bodies we have explained. Again, check the documentation for some properties you are not sure about. Also, you can maybe ask in the comments, and some persons will answer you. Okay, so if you like the video, press the like button, and if you're looking for other Unity videos, just check my channel. There are more of them, and I'm preparing to make much more of them in the future. So guys, that should be it, and I hope to see you in some of my other videos. Cheers!